Yes. Depositi Sharma, yes.
Yes, sir.
Okay. And if we are not using any negative numbers, suppose if we are not using negative number means what? By default, the number is positive. That time what happened? Positive number, actually it is similar to the sign magnitude form. So when we are computing with positive numbers, that time what happened? Complement is not required. Okay. Now what happened? Designer means the digital circuit designer or logic designer. What happened? They are finding some type of things, because what happened? Changing the circuit and modifying the circuit is very complex. Okay, and it is very costly. So suppose what happened, if A plus B, if we are using two particular variables, if we are designing one particular circuit where that particular circuit perform the two variables, adding the two variables. Okay, so what happened? Now what happened? We are human beings, so we are considering the variable. But when we are going to the digital circuit, variable goes to the binary numbers. So that time what happened? Only for two variables, the circuit is somehow we are designing very not a complex circuit, but it is some particular time is required. For a small circuit, though, it is time is required. Okay. So for that particular purpose, designer thinking that why we are using only one circuit, and that particular circuit we are using for different operation. Okay, they are thinking like that. So what happened? When we are performing the subtraction, that time what happened? This particular complement concept is coming. So always remember, when we are using the negative numbers, that time what happened? We are using the ones complement also, as well as twos complement also. Now second question is that, now ones and twos complement, both the competition process are similar? No, they are not different. They are totally, there are some particular competition processes different. When we are using the ones complement, you know how we can convert into the ones complement, and based on that particular conversion, how we can use for arithmetic operation. That means subtraction or addition. Okay, addition is not required, subtraction is required, because addition we are not using any complement. But the numbers are positive, then no need to doing the complement. Okay. So ones complement, earlier the last class we are discussing how we are doing the ones complement. Now second thing is that second thing is that the twos complement also different. Okay, it is not as similar to the ones complement. We are using some particular process. We are discussing some particular step, how we are doing the ones complement, how we are doing the twos complement. Now what happened? You are talking about the which particular, when we are using the ones complement and when we are using the twos complement. See, generally what happened, inherently when we are doing the twos complement, the inherent process of ones complement already inherent in twos complement. And remember one thing, so we are going some particular, suppose we are designing the circuit such that the competition is not a very complex, it is very simple, such that we are getting the output very fast. Okay, and suppose power dissipation, now these days what happened, power dissipation is very it is a challenging issue. So what happened, we require such type of competition where the circuit is taking the minimum time or less power is required. So what happened, for a particular purpose, twos complement competition is less than ones complement. By default, people are not using ones complement. People are using generally twos complement. Because why? Because the process is very simple. The competition process is very simple. But in question, if it is mentioning that and someone is asking you specifically, now, no, you are doing the ones complement, then you can apply the method of ones complement. And someone is asking, yes, you can do the twos complement. Please, you use the twos complement. Then you can use the twos complement. But by default, people are using twos complement because twos complement is similar than the ones complement. Okay, Deepavali Sharma, are you getting?
Yes, sir. I got it. Thank you, sir.
Okay, so today we are going to start so another topic, not another topic, it is the part. So directly I am moving to the slide. Okay, and right now it is 46, and after that now it is 10, 8. Most probably 2 and 3 people are there remaining. Okay, no problem. Just a minute. Kapil Dev Kumar, Manojit Port, Mahanta Das. Okay, I am taking the attendance. Okay, no problem. So, and And remember one thing, when I am closing the meeting or when the class will be over, that time what happen? Before I am leaving, just you leave. Okay. So today we are discussing the complement. Now, yes, now it is sometimes what when it is the paper, some particular concept is very lengthy, so don't confuse. Now, till now we are discussing about yes, obviously the decimal number, obviously directly or indirectly we are using. But what happen if we are using complement? Not we are not using the complement in the binary numbers. That time what happen? Also we can use the complement of decimal numbers. Okay, and complement of decimal numbers based on this particular concept, ones and twos complement concepts are coming. Okay, now we are today we are discussing some type of complement which we are using in decimal number, and after that directly I am going to the binary codes, because some though we are not using this particular complement of decimal numbers, but you have to know. Okay, so now what happens when complements in decimal numbers? That time two type of complements are there. It is called a nines complement and it is called a tens complement. And remember, nines and tens complement we are not using in binary numbers. Always we are using in decimal number system. So though digital circuit, actually we are using a binary, when we are designing the digital circuit and all those things, that time what happened? The binary numbers actually, we are playing with the binary numbers, not a digital numbers, or sorry, decimal numbers. But what happened? Also, what happened? Sometimes what happened? Decimal number. We have to know that this particular binary sequence belongs to which particular decimal number. So indirectly or directly, decimal number concept is required. So you have to know how we can doing the complement for decimal numbers. So when we are using the decimal numbers, two type of complements are required. One is called a nines complement and another is called a tens complement. Let's see what is nines and tens complement. The first point, the nines complement, the nines complement of a decimal number is obtained by subtracting each digit of the decimal number from 9. Okay, so that means what happens when the some particular decimal numbers we are getting, that particular decimal number we can subtract some on the number of from the number of 9. Okay, that is called a nines complement. And tens complement of a decimal number is obtaining by adding 1 to this nines complement. That means it is similar to the twos complement in binary sequence. When we are doing the tens complement, that time always remember we can use the nines complement, and lastly what happens, we can add the adding 1. Okay, that is directly convert to the tens complement. Now we can check that what are the steps are required when we are doing the nines complement of a decimal subtraction, because anyhow sometimes what happen, we are using the decimal subtraction. The subtraction is required for complement, you know already. Okay, so obtain the step 1 is what? This particular step 1, obtain the nines complement of the subtrahend and add to the mean. Now what happen, you can know this particular concept. I hope you know what is the subtrahend and what is the mean. Okay, suppose 25, if we are using 25 minus suppose 15. Okay, so whatever the result is coming, this particular whatever the result is coming, this particular result part is called a difference. What is called? This one is called a difference. Okay, this one is called a difference. Okay, and this particular 25 is called a mean. M-I-N, this one, M-I-N-U-E-N-D. And this particular minus 15 is called a subtrahend. Okay, don't confuse this one. When we are subtracting something, there are three particular terms we are using: subtrahend, mean, and difference. Okay, Though we are using some particular terms, we are using borrow and something, it is defined, but what happens when this one is called a, the first one is called a mean, second one is called a subtrend, and whatever the result is coming, it is called a difference between the two numbers. Now what happens, step 2, what actually we are doing in step 2, call the numbers in the intermediate result. We can check what are the intermediate results are there. Okay, we can return the intermediate result. Okay, and after that what happen, step 3, if the carry, if there is a carry, okay, it is indicate that the answer is positive. These particular rules you have to remember, otherwise what happens, sometimes it is confusing, very confusing, because we are, this type of rules we are getting in many competition. So don't conflict this one. Okay, if there is a carry, so these particular things only you can do through practice. Okay, without practice you can confuse. Yes, these particular rules we are using in ones complement or twos complement or BCD or nines complement. So you have to remember. So step 3 means what? If there is a carry, if carry is generated, if there is a carry means what? Carry is generated. It indicates that the answer is positive. It is very simple. If there is a no carry, that time what happens? It is indicate the answer is positive. Otherwise, it is not mentioning anything. So don't use otherwise here. Just you can read the step 3. Now what happens next? Add the carry to the LSD. So we can bring that particular carry to the LSD of this result to get the answer. Okay, you know what is MSB and LSD. After that, whatever the carry is called, that particular call also it is similar. Whatever the carry is generated, that particular carry is called an around carry. This one is called an around carry. Okay. Step 4, if there is no carry, suppose carry is not generated, that time what happens? It indicates that the answer is negative. Instead of positive, now it is answer is negative. And the intermediate result is nines. The intermediate result is in the nines complement. Okay. Now what happens? Takes the nines complement of this result and place negative sign in front to get the answer. It is very simple. The procedure is very simple. That means there are some particular rules are there. We have to follow the rules. Okay. So what happens? How this particular procedure actually work? With the help, now we are describing with the help of example. See here, nines complement. Suppose we are interested to do the nines complement. Till now we are not discussing about a tens complement. Remember, we are talking about only for nines complement. So example means what? Nines complement of the following decimal numbers. We are interested to do the following numbers. This part. At first we are discussing 3, 4, 6, 5. So 3, 4, 6, 5, how we are converting to the nines complement from? Simply we can subtract this particular 3, 4, 6, 5 from 999 by using 4 nines, because here 4 decimal numbers are there. So here number of how many numbers we are using? 3, 4, 6, 4 numbers we are using. So 4 9 digits are required. Sorry, here it is some mistake. Just a minute. Oh. Okay, so what happened here? This one we are using 6534. Now what happens similarly? If we are using fractional part, that time also what happens? How many numbers we are using with the up to fractional? 1, 2, 3, 4, 5, 6, 7. 7 fractional 7 digits we are using, including the fractional part. So how many nines digits we are using? 7 number of 9 digits we are using, and this particular we are subtracting. Okay, so whatever the number is generated, that is called a just a minute. This particular number is called a nines complement of 4526.075. So whatever the result is coming, this particular result is called a nines complement of 4526. That means what is the nines complement of 4526.075? The answer is 5473.924. This one. Okay. And if someone is asking you what is the nines complement of 3465, the nines complement of 3465 is this one, 6534. Okay. If any doubt, then please ask me. Don't keep silence. Now what happened? This is very easy. This particular part is very easy. It is simple. We are not using any particular, whatever we are discussing the process and all those things we are till now we are not discussing. Okay, that means process means what? This particular procedure. This particular procedure. This particular is 4 step we are using when we are applying this one. Subtract the following numbers using the nines complement. Okay, because instead of subtraction, if you are using the addition, that time what happened? The meaning is same. The meaning is something different because we are not using any complement in the positive side. It is similar. It is similarly to the. It is very easy or similar to the sign magnitude. So what happened? Now what happened? This particular, which particular one? This one is positive. Then we are not using anything here. We are not interested to do the nines complement of 74.81 because this particular number is positive number. Now we are interested the nines complement of 436.62 because what happened? In front of the number here minus sign is there. Okay, so at first what happened? We can 999.99 we can use minus 436.62 just like a nines complement form. So what happened? So we can generate the nines complement of 436.62. So what we are getting? We are getting 563.37. Okay. After that, what happened? We are using this particular. Sorry, this one is again some particular mistake is here. This is not a minus actually. Okay, so what happened? This particular number we are adding with 745.81. Now what happened? See here. Now see here. This particular carry is generated. One. This is the carry bit. Also, this one is called an around carry. This one is called also an around carry. So what happened? According to our procedure, if there is a carry, it is indicate that the answer is positive and add the carry to the LSD. So we are using this particular one to this particular one. Okay. So what happened? Here it is coming 8 plus 1, 9, 1, and this one 3, 0, and 1. And this particular carry bit is no more here. We can add to the LSB. Okay. Now similarly, this one also we are using because see here we are again what happened? We can 254 this one 25418 is the ninth complement of 745.81. So what happened? We just adding to the 436.62 and we are getting 690.80. And what happened? We can just here when we are getting the 690.80, that time what happened? There is, see here, how many before fraction, how many digits we are using? 3 digits. Here also the resulting answer also we are getting the 3 digits. That means what? The carry is not generated. When the carry is not generated, what it is saying that if there is, see here, if there is no carry, step 4. If it is there is no carry, it indicates the answer is negative and the intermediate result is 9's complement form. So which one is the intermediate result? 690 is the intermediate result. Now it is behave like the intermediate result because there is no carry generated. Okay. So what happened? If there is no carry, obviously what happened? We can write the whatever the answer is coming, we can write in the minus sign. Okay, this one is the minus sign. And again, what happened? We are doing the 9's complement of 690.80. So 69.00. How we are doing this the 9's complement? This one is the 9's complement. And whatever result we are getting, before that we are using the minus symbol. So that is the 309.19. The correct answer is 309.9. This way we can complete this particular whole the procedure. Okay, any doubt?
No, sir.
Any doubt?
No, sir.
No, sir.
No, sir. No, sir. No.
Now we are going to the tens complement form. Till now we are discussing the nines complement. Now how we are using the tens complement for a decimal subtraction. So what even obtain the tens complement? How we can obtain the tens complement? Already I am discussing this one. The second point is the called a tens complement. The tens complement of a decimal number is obtained by adding 1 with nines complement. So remember when we are using the tens complement, always we can complete this particular first one. That means we are complete the process of nines complement, and after that we can add 1. And when we are adding with the nines complement form, that time whatever it is called a tens complement. Okay. So obtain the tens complement for the subtrahend. Okay, and add it to the mint. Okay. So you know already, I have already discussed what is the subtrahend and what is the mint. Okay. And if there is a carry, if carry is generated, then ignore it. The presence of the carry indicates that answer is positive, and the result obtained itself the answer. That is very simple. Step 2 is very simple. If step 3, if there is a no carry, it is indicate that the answer is negative and the result obtained is tens complement. Obtain the tens complement of the result and place negative sign in front of it. So just follow this particular procedure. Okay. So here 4069, we are using the nines complement. Sorry, this one is this particular up to this particular part is what? This is called a nines complement. Just a minute, just a minute. Hello. Yes. 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 Just complete my class and after that. So this one is called a nines complement. Now what happened till now it is not a nine, it is till now it is not converted to the tens complement. After that, when we are adding the plus 1 in the LSD, that time what happened? We are getting this one 5931. Okay, 5931. So this one is called a so see here. This one is the tens complement. Tens complement of 59. Here we are not using this one. It is not required. It is simply the tens complement formula. We are not using. Why I am deleting this one? This one I am deleting because till now we are not using decimal subtraction. Thus we are converting to the tens complement. That means only this particular number we are converting to the tens complement form. The same things, the same concept we are using here. That means what? 1056.074. So at first thought when we are converting to the nines complement form, this one is the nines complement form. This particular part is called a nines complement form. Okay. And when we are adding to the LSB, that time whatever the number is generated, this particular number is tens complement of 1056.0. So this way we can complete the tens complement. But when we are going to when we are using the tens complement in decimal subtraction, that time we can follow the 3 step. Okay, how we can follow this? We can check this one. So here we are using the tens complement form. This one is the tens complement form. So again we can convert to this one, we can convert to the tens complement form. Okay. So when we are adding 1, that time this one is the tens complement form of 416.73. After that we are adding with this particular number. Now if carry is generated. Which one is the carry? This one is the carry. 1 is the carry. 1 is the carry. Because how many numbers are there? 1, 2, 3, 4. Here, how many numbers are generated? 5 number is generated. And most MSB is the carry bit. Okay. If carry is generated, that what is if there is a carry, step to see if there is a carry. Ignore it. The presence of the carry indicates that the answer is positive and result obtained itself is the answer. So see here, this one is the carry, one is carry. So what is the correct answer? Correct answer is 2511.18. And just simply we can ignore the carry. So what happens when we are applying the tens complement? It is simple. It is little simple than the nines complement. Okay. Now same thing if we are using this particular example B. That time what happens? We can find out. We can determine the tens complement of 2928.54. And we are applying the tens complement here. Okay, with adding +1. And after that, whatever the value is generated, 7071.46, we are just simply, we are adding with 416.73. Now remember, down before fractional, how many numbers are there? Decimal numbers, 1, 2, 3, 4. But 4163 only 3 numbers are there. So we are extra 0 is added. It is meaning is same because we are not using any binary sequence. We are using all the decimal sequence. Just simply we are adding. See here when we are adding, there is no carry is generated. Earlier example, there is a carry is generated. If no carry is generated, that time what happens? If no carry, it indicates that the answer is negative. That means whatever the answer is coming, it is negative. Okay, you just simply assume that the answer is negative. And the result obtained in tens complement. And whatever the result is coming, this particular result, again, we are converting to the tens complement form. This one is the tens complement of this particular number. Okay. And after that, what procedure says that obtain the tens complement of the result and place negative sign. Just we can simply place the negative sign, whatever the result is coming in front of the result. So minus 2511.81 is the correct answer. This way we can complete the process of tens complement for decimal subtraction. Any doubt this one?
Sir, in the first part, answer will be 2511.81.
Yes, correct. 2511.18. Yes, correct. Not a, because we are ignore the carry, na? We can no more carry we can consider.
Yes, sir, I got that. Sir, actually the point it will be 0.81, not 18.
Most probably because when I am preparing the PPT, just a minute, I will check. Okay, just a minute.
Yes.
This one most probably it is here. You are talking about this one, no? Tens complement. Tens complement. 251. Yes, correct. Yes. Just a minute. Yes. Thank you. You can consider this one. Now it is okay.
Yes, sir.
Yes, sir.
Yes. So this is the concept of nines and tens complement, but rarely we are using. But someone is asking you what is the meaning of nines and tens complement, why we are using. So this particular concept, it is required. Okay. So it is also essential to know this type of concept also. Though we are not using very much in nines and tens complement in digital circuit or digital electronics. Okay. But anyhow, the binary numbers are decimal numbers are related to the binary numbers. You cannot just simply avoid the decimal number. Okay. Now see here, the first class, the introductory class or second class, I forget actually. We are dividing the different type of numbering system. We are dividing the numbering system in two particular parts. One is called a weighted code, and one is called a unweighted code. Are you remember, na? This one. So
yes,
weighted code, weighted code means what? We can based on the bit position, we have declared some weight, and if that particular rule is in some particular bit sequence, the follow that particular rule, and that type of bit sequence is called a weighted number. And some particular binary, some particular code, they are not following the rule of weighted code. Okay, that time what happen? This particular is called a unweighted number or unweighted code. Sorry, unweighted code. Now you can ask me why we are using this type of unweighted code. Sometimes see the manipulation of binary sequence, it is sometimes very difficult. I am talking about not a hardware point of view. I am talking about suppose as a user point of view, okay, or suppose this designer point of view or developer point of view. Okay, sometimes what happens when we are maintaining when we are designing some particular record file, or suppose when we are going to DBMS, database management system, or different type of subjects are there, that time what happens, a lot of things actually required with the help of binary sequence, or we are using the concept of binary sequence. Okay, that time what happens, the conversion of binary sequence is very difficult, or what happens, some particular cases it is very difficult to maintain the binary sequence. Okay, though we are using in digital circuit, yes, but sometimes what happen for user perspective, that means this type of decimal number coding system is sometimes it is used. So what happen, decimally sometimes for manipulation purpose we are using decimal type of concept. Okay, but remember, after all what happen, computer understand only 0 and 1. So anyhow what happen, whatever you are thinking and whatever, ultimately what happen, it is converted to the binary form. But what happen, for manipulating, for designing or something, that time what happen, if instead of binary numbers, if we are using decimal concept, that time what happen, it is easy for us. For that particular concept, different type of binary codes are generated. Okay, suppose you know the so numbering system, the hexa, octal, whatever. So what happens, some type of unweighted binary codes are important for us to manipulate this type of things, because it is very easy, or maintaining some type of sequence such that the automatically our computation process is simple or easy. So one is unweighted binary code is called a binary coded decimal. Okay, remember, it is called a binary coded decimal. Okay, and if you are going deeply in BCD, that time what happen, decimal to binary and binary to decimal conversion process is, we can do that particular conversion process. Okay, but remember, directly we are converting to the binary, again we are multiplying, or whatever we are doing binary to decimal, again we are multiplying, adding, and so if it is binary number is very huge, the sequence is very large, sometimes whatever it is time consuming. It is okay, we can compute, but it is sometimes time consuming, or sometimes it is complex. So what happen, because if we are talking about the 8-bit, 12-bit, it is okay, we can do. But if when it is going more than 36-bit, that time what happen, it is conversion binary to decimal, not a for computer purpose, not a very difficult, but when we are taking the human, when we are doing, that means it is very complex. Okay, so how we can minimize that particular problem? Okay, so what happen, some particular code word we are using, some particular code sequence we are using. Okay, that type of code sequence, one is called a binary coded decimal, and shortly it is called a BCD. It is called a BCD. Okay. So what is BCD? BCD code is one in which digit of decimal numbers encoded one at a time. So what I mean? In which digit of decimal numbers are encoded. That means what? BCD automatically, indirectly, it is related to the decimal number. So it is capturing or storing some particular decimal number. Remember, BCD capturing or storing some decimal number are coded one at a time. Okay, one at a time. But remember, when we are encoded, that particular decimal number, how many bits are required? Remember, when we are using only 4-bit binary equivalents are required. That means 4-bit group sequence are required. One particular group, you have maintained only 4-bit. If it is one particular group, we have more than 4-bit, that time what happens? It is no more BCD. So when we are talking about the BCD, always remember, one particular group, we are using only 4-bit. This one 4-bit. That means what? 4-bit binary equivalent. That is the important point, first one. Now second one, you know, if we are relation with the decimal digit, you know, any particular binary sequence, if that particular sequence have a sequence, that particular sequence has only 4 bits, that time what happen? How many decimal numbers we can represent? Only 0 to 9. Are you getting my point? When decimal number going to 10, that means beyond than 9, that time what happen? How many bits is required? Binary bits are required. It is more than 4 bits. Because 4 bits we cannot represent decimal number 10. So what happen? When we are talking about the BCD in decimal digit, that time what happen? The range is 0 to 9. If it is exceed 9, that means 10, 11, 12, these particular things we cannot represent with the help of BCD. And also, it is very interesting. See here, if we are forming any particular decimal digit, suppose just a minute. Suppose if I'm using, suppose decimal digit is 1, 2, 3, 5. So what happened? Here also 1 is present here. 2 is also present. Though it is one particular digit, big digit, 4 digit. 2 also there, 3 also there in this particular range, and 5 also is there. So any number you can represent with the help of 0 to 9. So this way, that means this particular concept is created. Okay. And also remember, the very interesting thing is that conversion process is much easier. So because what happen, we are using suppose group of 4-bit, that time what happen? Based on this particular concept, we are converting this. Okay. So that particular part, we'll discuss very soon. Okay. Now what happen? What is the advantage of BCD? The main advantage of this particular code, it is easy. That means easy is model of what? It is efficient. Okay. Of conversion to and from decimal. This is the big disadvantage of BCD. Okay. That means what? The conversion process from binary to decimal or decimal to binary, it is very easy. So it is called a conversion to and decimal, to and from decimal. And there are also some disadvantages also. So it is less efficient than the pure binary. Because we are grouping with 4-bit binary numbers, that time what happens? We are not maintaining the pure binary. When we are discussing the BCD, that time what happens? We are not follow the property of pure binary. Pure binary means what? We are using suppose 0, 0, 0, all bits are 0, 0. After that what happens? The sequence is 0, 0, 1. After the next sequence is 0, 1, 0. So it is we are maintaining some particular pure binary with the help of some particular weight. Weight is what? 2 to the power 0, 2 to the power 1, 2 to the power 2, something like that. Some particular binary properties we have to follow. But when we are talking about the BCD, that time we are not maintaining any pure binary form. That time what happen? Sometimes what happen? The concept is something different. Okay. So we are not maintaining the pure binary form. So BCD is called a unweighted binary code, or it is not weighted binary code. Okay. So in the sense that it is requires more bits. To represent, it is required more bits. Why it is required more bits, we will discuss after this particular slide, or after 2 slides. We are discussing why it is required more bits. Also, second point is also important. There are 6 illegal combinations. So someone is asking you, how many illegal combinations are there? 1, 2, 3, 4, 5, and 6. Someone is asking you, how many illegal combinations are present in BCD code? That time your answer is 6. Now, why it is coming? Why this particular number? This is also 4-bit. Oh, sorry. Here I am saying something. 0 to 9. Okay, 10 also we are representing. 10 also we are representing. Earlier we are saying that 10 is not a representing with 4-bit, but yes, 10 is representing the 4-bit. So what when we are just decimal number we are considering, just you can just simply the range is 0 to 9. Okay. So what when after 9, whatever the numbers are generated, all the numbers are illegal numbers, not a legal numbers in BCD. So this one is 10, this one is 11, this one is 12, this one is 13, this one is 14, and this one is 15. Okay, so this particular binary sequence up to 10 to 15, this is called a illegal combination or illegal binary sequence of BCD. Any doubt up to this one? Any doubt?
No, sir.
Hello?
No, sir.
Hello? আচ্ছা বলিয়ে আপুনি কোন দিকে আপুনি কোনখানে আছে আপুনি না আপুনি কি মানে ইউনিভার্সিটি গেটে আছে না কোন দিকে আছে আচ্ছা আপুনি না মানে ফটো সময় আহিব ঠিক আছে আপুনি যত সময় আহা আমাক কন্টাক্ট কৰি দিব হা ঠিক আছে So this is the BCD. Next, see here. So how we are representing the decimal 238 in the BCD form. So see here 2, we are representing, we are making with 4 bits. This particular 2, this one. We cannot exceed more than 4 bits. So 0010, 3 we are representing this one, 011, 8 we are representing this one. So this way we can represent 238. So see here, every particular digit we have to require 4 number of bits. So what happened? Our disadvantage of the first point that means see in the sense that it requires more bits. So sometimes what happened to manipulating many number of binary sequence are required. So it is called a more number of bits are required. That is the one disadvantage of BC. Okay. So 12.39 in decimal number, how we can convert to the decimal? So what happened? This one, see 001, this one is 41, 001042, 0.00011 is 43, and 100149. Okay. So in K digits, how many total number of bits are required? K digits equal to 4K bits. See here, here how many digits are there? What is the value of K? K is 1, including the fractional part also, 1, 2, 3, 4. So 4 into 4 means what? 16. You can count this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 bits are required. See here, how many bits are there? In the first example, 238, 3 number of K digits are required. So 3 into 4 means what? 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this way we can consider. Now this particular table, we are discussing different form of sequence of binary digit. So there are different form of binary digits are there, and which is also called a code word. This particular part, code word also it is very much essential. So in some particular other topic also it is required the concept of code word. So you have to know the basic concept. So till now we are considering only BCD. We are discussing only BCD. So BCD means what? BCD is maintaining this particular form. 8421. 8421 means what? So 4-digit combination what happened? This particular 8421 we have to, actually we are maintaining. Okay. But it is called a 8421. And BCD is always BCD term, manipulation of BCD is something different. So 238 means what? 2 we are representing with 4 binary sequence, 3 also we are representing 4 binary sequence. So always you remember BCD is unweighted code. Okay. And the every digit we can form with the 4 bits groups. Okay. And what happened? there are 6 illegal codes because the range of BCD in decimal, it is 0 to 9. So whenever it is occur 10, 11, 12, 13, 14, all are all illegal codes or illegal numbers. Okay. So someone is again asking you how many numbers of illegal codes in BCD, then your answer is 6. Okay. So see here in this particular table, this one 8421 is one type of weight, 2421 is another type of weight. That means position. It is not a weight exactly, it is position. Okay. 521, it is the position. Okay. 5421, 642 minus 3, 84 minus 2 minus 1. And these are the decimal digits. See, I'm not discussing whole the tables, just you can see if you are considering 8421 and if you are considering 3, that time what happened? 8 is deactive, 4 is deactive means what? 0, 4 is 0, and 2 is 1, active, that means 1 position is active. That means what? 2 plus 1 is 3, so 1, 1, 0, 0, 1, 1 is there, 0, 0, 1, 1 is there. Because what happened? This particular 1, 1 is representing 3. Okay, if you are considering 2421, that time what happened? Same, because here 2121 is there, 2 plus 1 is what? 2 plus this one, 2 plus 1 is 3. So 24 is deactive and 21 is active. See here, 24 is 0, 0 and 2 is 1 and also 1 is 1. Okay, if you are going to 5211, that time also you can active this particular one also, 1, 1 also, or you can active this particular 2 also, because here 2 is 1, this particular 2 is 1, and this particular 1 is 1. अब ये अब थोड़ा देर के बाद फोन कीजिए, मैं क्लास में हूँ. हाँ थोड़ा. So 2 plus 1 means what? It is also representing 3. Okay. If we are going 5421, that time what happened? 0, 0, and this one also 2, this one is also 2, and this one is also 1 also active. The position of 2 also active and position of 1 also active. But when we are going 642 minus 3, that time see here, 6 is active. This particular 6 is 6 is active, and also 3 is active. So 6 minus 3 means what? It is representing 3. This particular 3. Okay. And 842 minus 2 1. So that time what happened? 4 minus 1. So 4 is active and minus 1 is active. So it is similarly for other also 5, 6, 7 also we are doing this. Okay. And this is the defined form of the sequence of binary digits. So defined forms, it is 8421 form, or it is 2421 form, it is 5211 form, or sometimes it is called a 5431, sometimes it is called a 642 minus 3, sometimes some form is 84 minus 2 minus 1. Any doubt this one? So any doubt?
No, sir.
Yes, sir.
Okay.
सर वो सर डेसिमल ट्री का 5211 फिर से समझाइए.
5211. Okay, very good. So where what happened? Just we are considering some another one. So ये हो गया है, jump हो गया है. Suppose we are describing this one. So this one is what? When we are considering the 6 digit in 8421, it is very simple, because what happened? 0110. Already you know. So when 2 to the power 0 into 0 means what? 0. 2 to the power 1 into 1 means what? 2, and 2 to the power square means what? 4. So 4 plus 2 we are getting 6. So 8421 is already we have done. That means there. But how we can consider 5211? See, 5211 means what? So what is the decimal digit? Decimal digit is 6. Okay. So if we are active means what? See, sometimes what happen in decimal digit, in decimal circuit, 1 is called a high. You know already, suppose high. And also it is called sometimes it is called a active. Based on which particular situation we are using. Sometimes what happen, it is called a active. Okay. and sometimes it is called a on. Okay, but when we are using 0, what happen? Instead of high, we are using low. Instead of active, we are using deactive, and instead of on, we are using off. So see here we are talking about 6. Now what happen? I am telling that 5 is active, 5 position is active. Now which particular position we are going to active such that we are getting the 6, decimal digit 6. So obviously 5 plus 1 means what? 6. So we are active 1, because this one is coded 5211. Okay, so 5 plus 1 means what? We are getting 6. Doubt is clear?
सर 5211 में 6 जो बोला था ना, 5 एक्टिव किया और हमने 1 एक्टिव किया, तो सर 2 के बाद वाला 1 वाला क्यों किया? हमने लास्ट वाला 1 क्यों नहीं किया एक्टिव?
नहीं, तुम कर सकते हो, वो भी कर सकते हो, नो प्रॉब्लम. Just
कोई भी 1 एक्टिव करने से चलेगा?
yes. This if instead of this one just 1 0, ठीक है, मैंने ये एक्टिव किया, सपोज मैंने ये एक्टिव नहीं किया, ठीक है, इसको मैं 0 कर दिया और इसको मैं 1 कर दिया, तभी करेक्ट होगा. बट यू ट्राई टू प्रोड्यूस द यूनिक नंबर. ठीक है, तो यहाँ पे अगर कोई एक जगह में फिर से ये रिपीट हो रहा है तो वो पोजीशन को फिर से कंसीडर मत कीजिए. Generally we are not using, but conceptually this type of binary sequence form is required to understand. Okay, this is the only bit position. So which particular position is, what is the, actually it is the, which particular position, what is the weight actually? These all are the weights. Are you getting my point?
Yes sir.
Okay. Now how we are using the concept of BCD numbers, how we are doing the arithmetics. Okay, if we are using BCD in arithmetics, that time what happen? It is called a BCD arithmetics. So obviously you know in arithmetics there are some type of addition, subtractions are looked at. Till now we are not discussing the multiplication. Multiplication we are not bothering about that. So we are only considered addition and subtraction. Okay. So when we are using the addition in BCD addition, how we are performing the addition in with the help of BCD. Okay, just you check. See, in BCD addition, perform individually adding the corresponding digit of the decimal numbers expressed in 4-bit binary groups starting from LSD. Just we can follow the concept of, we can follow the definition of BCD, and we can starting from the 4-bit binary groups, and we are starting from the LSD. LSD means what? Least significant digit. Okay. Again, if there is a carry out of one group to the next group, if that means carry is generated, or if the result is an illegal code. There, remember, in this particular second step, there are two particular conditions. One is condition is that if there is a carry out of one group to the next group, this is the one condition. And second condition is that if the result is an illegal code. If anyone out of two, anyone is satisfied, that time what happen? We can compute this particular process. What is the process? 6. Now we are representing 6 means what? This is the decimal digit, and when we are representing in binary form, we are writing 0110. Is added to the sum term of that group. Not all the group. Remember, of that particular group. Okay, where the carry is generated. And the resulting carry is added to the next group. Whatever the carry is generated, we are using the next group. And this particular process, this particular computation, we are applying if illegal codes also occurred, or another one is what? If carry out of the one group to the next group. If both this particular condition, condition is completed or fulfilled, that time what happen? We can add 0110. Let's see with the help of example. You can study this particular two condition at first. Okay, and now you can this particular concept directly we are applying with the example. Now if you are getting any doubt, then you can ask me. See here, 25 plus 13. So this one is the BCD form of 2. 2 means what? 0010. And why I'm using 4-bit? Because you know BCD making a 4-bit group only, not more than that. So 2 we are grouping with 4-bit 0010, and 5 we are grouping with 0101. Same thing 1 for 0001 and 3 for 0011. Okay. After that, what happen? We are adding 1 1 plus 1 0 1 0 1 1 plus 1 0 1 1 plus 1 0 1. So see here, there is no carry generated. And also you remember 0 1 1 means what? It is representing as a 3, and this one is representing as a 8. But when we are considering from in BCD 0 to 9, 0 to 9, what is the range? Range up to 9. So 3 also include in this particular range, and 8 also include this particular range. So there is no illegal code is generated. So what happens if there is no carry is generated and there is no illegal code is generated? So whatever the answer we are getting, that is the correction. Now see here, in next example, this particular part we are doing the same thing. This particular part just we are simply the adding this particular part. Now see here, 0 0 1 plus 1 0 means what? This one is 0 and this one is carry is generated here. 1 plus 1 plus what? 0. Carry is generated, that means double 1. So here also carry is generated. So this particular extra carry is coming. Okay, this one is the extra carry bit. And when we are adding triple 1 1 1 1 1 with this particular one with 0 1 1 0 0, that time also what happens? This extra carry bit is generated. Just you are adding. Okay. And also what happens when we are adding with 1 0 1 0 and 0 1 1 0? Oh, sorry. Sorry. This part before that one, why we are using this one 0 1 1 0 0 1? Because step 3 says that if anyone this one, if this particular condition is true or this particular condition is true, that time any one condition is true, that time what happens? We can add 0 1 1 0. So we are adding 0 1 1 0 because see here, 1 0 1 1, this one 1 0 1 1 is the illegal code of BCD. 1 0 1 0 also illegal code of BCD. 1 1 1 1 also illegal code of BCD. And 1 1 1 1 0 also illegal code of BCD. When the illegal codes are occurred, that time what happens? We are adding 0 1 1 0. Because what happens again? Why we are adding 6? Because again we are going to our initial state. To reach the initial state, we are getting the plus 0 1 0. So why we are adding 6? Someone is asking you why we are adding 6. Why we are not adding 8 9? Because what happens? There are 6 illegal codes are there. So what happens? We are adding only 6, not a 9 or not a 8 or not a defined number. Okay. So we are adding 0 1 1 0 0 1 1 0 0 1 1 0 0 1 0. After that, what happens? When we are adding this type of numbers are generated. And when the numbers are generated, again carries occur. That time what happens? See here, some term of that group and the resulting carry is added to the next group. So this particular carry is we are adding with the next group. This particular carry we are adding with the next group. This particular carry we are adding next group. This particular carry also we are adding next group. And simply we are adding, and this particular, the output is coming in this particular. This is the output. Now you can add 6 7 9. What we are getting? 679.6 plus 536.8. What we are getting? Just adding this one, 679.6 plus 536.8. What is the answer? Answer is coming 1 2. Answer is coming 1 2 1 6 point. So if you are converting in the binary sequence, we are getting the same answer. 0 0 1 means what? This one is 1. 0 0 1 0 means what? This one is 2. Again 0 0 1 means 1. 0 1 1 0 means 6. Point 0 1 0 0 means it is 4. It is clear or not? Any doubt? Any doubt?
No, sir. No, sir.
Okay.
नींद आ रहा है क्या आप लोगों को? Yeah, correct.
No,
No,
sir.
fine. I didn't. Yeah.
No, sir.
That is the but we can okay, we can try some difference. We can on the video, and that time I will see your face. Okay. So this is the addition. And what is the subtraction? In subtraction, perform subtracting the digit is 4-bit group and the subtrahend from the corresponding 4-bit group, and the 6 is subtract from the difference term of that group. So see here, if no borrow is generated, then whatever the result, what is the sum is coming, this particular is the correct difference. Okay. If some particular illegal codes are generated and borrow is generated, that means what? You subtract 4 digit of the subtrahend, the corresponding borrow. So if some particular illegal codes are there, that time what happen? Illegal code or borrow is generated, that time what happen? Or no, borrow is not mentioning here. Some particular illegal codes are coming, that time what happen? We can subtract 0, 1, 0, 0, 0, this one. Of BCD, 1110 is the illegal binary sequence of BCD. So where the binary sequence are occurred, that particular group only we can minus subtract 0, 1, 1, 0. Now what happen? I have already discussed, because minus is it is difficult. That means competition is difficult instead of plus. That time what happen? You can convert this particular -6 with that 2's complement. Direct -6 we can convert to the 2's complement from. Okay. And after that, whatever the result is coming, just you can adding this one. If you are not interested to doing the minus. Okay. Just you can convert -6 into 2's complement from, and whatever the value is coming, instead of minus, just we are adding, then the same value is occurred. You can just try and check it, the same value is coming. Okay. And you can add, you can minus 206.7 minus 147.8, whatever the result is coming, the same result is occurred here. You can check, cross check, you can do the cross check, no problem. Okay. Any doubt this one? BCD arithmetics subtraction?
No,
It is
sir.
okay? It is
Yes,
okay?
sir.
Okay, sir. Okay. Yes, sir.
Now what is a gray code? What is the time? What is the time? Today is only 1 hour, no?
6, sir.
Yes, sir.
Yes, sir.
11:06.
Oh, it is time is over, no?
Yes, sir. Yes, sir.
Okay, just a minute. We are going according to the timetable. You remember, Tuesday we have a 2 hours class. Wednesday we
Yes,
have
sir.
Wednesday we have a
1 hour
only
class.
1 hour class. But in some particular cases, what happen? If I am interested to take the 2 hours class on Wednesday, that time what happen? I will declare on Tuesday. That means I will take the to Wednesday. I will take the, instead of 1 hour class, I will take the 2 hours class. Okay. Otherwise, what happen? By default, on Wednesday, the class will be started from 10 to 11. Okay. Are you getting my point?
Yes, sir.
Yes, sir.
So you are interested to take the extra class on Saturday? Some problem? अच्छा, आप लोगों का थर्ड सेमेस्टर का कितना क्लास हो रहा है? बोलिए तो एक एक करके बोलिए। कितना क्लास? मेरा क्लास चल रहा है और
Math, English, analog.
ओहो, सॉरी मैं अभी आप लोग को छोड़ नहीं दूंगा तो आप लोग वहाँ पे ज्वाइन नहीं कर पाएंगे ना उस क्लास में। अभी मेरा पास तो आप लोग
सारे सब्जेक्ट का क्लास होता है सर।
क्या बोल रहे हैं?
मैं बोल रहा सारा सब्जेक्ट का क्लास होता है। सारे सब्जेक्ट का मतलब सारे का क्लास होता है।
नहीं वही बोल रहा हूँ, सैटरडे को तो क्लास नहीं होता है ना अकॉर्डिंग टू टाइम।
नहीं सर।
Saturday to you will free na Saturday. So okay, Saturday I will take 1 hour class 10 to 11.
Okay सर।
और आप लोग एक बार मुझे रिमाइंड कर दीजिएगा फोन पे, जो ये क्लास रिप्रेजेंटेटिव है, एक बार आप 8 बजे करीबन सुबह मुझे फोन कर दीजिएगा कि सर आपका क्लास है। कभी कभार मैं भूल जाता हूँ, ठीक है?
Okay sir, okay sir. Okay. Thank you.
Okay, just you leave one by one. Okay. And the rest of the part, this particular slide is not completed. We are just, you remember me, otherwise I am going to the next slide. Okay. So gray code till now we are not discussing, just we are discussing. Yes.
Sir, we don't have the proper syllabus, sir.
We are not getting the syllabus.
Yes, sir, we don't have the proper syllabus. What are the portions?
Okay, no problem. Today I am today मैं एक syllabus क्लास रिप्रेजेंटेटिव को मेल कर दूंगा, वो आप लोग को डिस्ट्रीब्यूट कर देगा, ठीक है?
Okay, sir.
उसको जस्ट व्हाट्सएप में ग्रुप में आप लोग फॉरवर्ड कर लीजिएगा, ठीक है? Also you can include me. मैं बहुत मुश्किल से एक WhatsApp group खुलाऊं. My number is behave like as a WhatsApp group, WhatsApp number right now. But I don't know your ये क्या नाम से आप लोगों ने इसको ग्रुप को ज्वाइन किया, अटेंड किया है, क्या नाम से? So you can just include my name, my ये number also in your WhatsApp. Okay. अच्छा, मैं प्रॉपर सिलेबस आप लोग को नहीं मिला, मैं प्रॉपर सिलेबस मेल करके दे दूंगा आज, अभी थोड़ा ब्रेक के बाद मैं मेल करके दे दूंगा. और क्लास रिप्रेजेंटेटिव कौन है? ये राजेश क्या, राजनी?
नो सर, राज.
हाँ, उसको बोल दीजिएगा कि उसको सबको डिस्ट्रीब्यूट करना, ठीक है?
सर, मैं बोल रहा हूँ.
अच्छा, ठीक है, गुड. अच्छा, जस्ट अ मिनट. ओके, just you leave the meeting. Okay, one by one. Just a minute. Okay, you can leave. Yes, no problem.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Sir.